Hi, I'm John, and my talk is about how to have MySQL DBAs understand operating either Cassandra or Scylla. I'll be basically talking about the various ways DBAs manage MySQL systems and comparing that to how you would manage a Scylla/Cassandra system. I'm John Shulz, and Principal Consultant for the Pythian Group, and I'm going to be talking about how you would run either Cassandra or Scylla if you're a MySQL DBA, kind of comparing what you do for MySQL versus how you would do it for Cassandra or Scylla. I've been in the business for a long time. You can kind of see I'm not exactly a kid anymore. I've been playing with data of one sort or another for the last 40 years. I work for Pythian. I have to put this slide in. They won't let me not put it in. We basically do managed services and database consulting on pretty much all the databases on the planet. We've got 11,800 servers currently that we're managing. There's roughly 400 people in 35 countries and about 2 millennia of experience. I guess I'm 40 years of that. And my agenda here, I'm going to start out talking about instrumentation. I don't know why I keep looking up there. I can look down here. I'm going to talk about instrumentation and why it's important. Then talk a little bit about the MySQL schemas and the Cassandra schemas. Then talk about some of the Nodetool commands, and then some of the graphical alternatives to using things like Nodetool and SQL queries. Instrumentation, why is it important? Basically, in order to manage software, you need to have it instrumented. You need to be able to see what's going on inside it. What does that basically mean? You get counters, things keeping track of how many things are happening, when, where, and how. Timers, how fast are things happening. Configuration, what are the current settings? How did I set that? What was my timeout set to? Commands, things like start it, stop it, change cache sizes, things like that. MySQL makes very, very heavy use of schemas, basically MySQL databases, to keep track of a lot of that information. Cassandra, Scylla use schemas as well. They call them keyspaces, but they're not as big a deal. Much more is done in other ways. Both use alternative commands to access this data. So start out talking about command line, which is how I kind of grew up. In MySQL, you have schemas. The first one is the MySQL database or schema. It contains information about identity, information about authorization, in other words, who I am when I'm logging in and what I'm allowed to do, the slow log, and a few other things. The information schema came about in MySQL 5, I think. Maybe it was 4. I think it was either 4 or 5. Basically contains information about table and view structures. You can basically see everything you want to know about your database. It also contains tablestats, counters, and information specific to storage engines, especially the InnoDB storage engine. Mostly it's, like I said, descriptive information and counters. Then there's the performance schema, which contains information. Basically, it contains a trace of the most recent SQL operations that are currently undergoing or just happened in the last few minutes. But it's very internals oriented, and almost no one has the knowledge or expertise to make sense out of it. So in 5.5, the MySQL community created something called the sys schema, which is for us ordinary mortals to try and understand what's going on inside the engine. Cassandra also has keyspaces schemas related to the system. The first one is the system schema. It contains information about your cluster. It contains information about all the nodes in your cluster, how they're configured. Think of it as the MySQL replication configuration. That's what's information that's basically stored in the system schema. I'm sorry, the system keyspace. System schema contains information that's very similar to the MySQL information schema with regard to information describing how the tables are formed, the columns, views, things like that. It does not contain counters. There are no counters in any of that's not really true. There's a couple minor counters. But for the most part, there are no counters in the Cassandra Scylla keyspaces. System auth, Scylla doesn't have that yet, but Cassandra does, and when they implement that for the open source, system auth will probably exist there in Scylla as well. System auth is the same thing as the old MySQL schema for keeping track of the users and their roles. Cassandra uses roles, unlike MySQL, which is each user has given a list of things he can do. In the case of Cassandra, each user is given a role, and the role is given things that he can do. It's an indirection, but it actually makes it much simpler to manage large groups of users. System traces is kind of similar to the MySQL performance schema, and very much like the original MySQL performance schema, it horribly impacts production performance. It's not something you want to turn on a normal basis. But if you want to get an individual trace of a command, a particular query to see what it's doing, it's really a useful tool. But you probably don't want to turn it on and trace everything, which is something that people actually do regularly now in MySQL. They finally got the performance schema to the point where it performs well. In MySQL, you've basically got show and describe. Those are the commands that you use most of the time to find out things of what's going on inside the system. Describe is basically something you describe tables. You can also describe queries. It's basically the same thing as an explain plan. So you can describe tables and queries. You can use show to show all kinds of things like the current process list, what queries are running right now, the show variables, which is going to give you information about what the current variable states are, both the local variables and global variables. You show global status, which is going to give you all those counters that are stored in Information Schema in a nice, big, quick dump. You can show table status, which will give you some really nice, useful information about basically, how big is your table, how big are your rows, how much index space you're consuming, things like that. There's lots more as well, but that's the basic stuff. In Cassandra, you've got Describe and Nodetool. Describe keyspace basically will tell you, Describe keyspaces will tell you how many keyspaces you have. That's basically telling you what the DBs are. It would be like show databases. Describe keyspace space name will display information about the keyspace. It's sort of like show create table, except it's going to show create table of all the things in that keyspace. You can actually say describe keyspace, because it's describe a table name, and it will just show that information for that one table. Nodetool is what we use for pretty much everything else. All this information is available via JMX for both Cassandra and Scylla. Scylla also has a RESTful interface that you can use as an alternative to JMX. But most people just use Nodetool. Nodetool connects to a particular server, and that gives you that server's view. And it's important to remember it's that server's view of the cluster. So if I issue a Nodetool command to one node in the cluster, and then I issue it to another node in the cluster, what I see may or may not be similar. You would hope that it'll be similar, but it isn't necessarily. And that's kind of an important thing to remember with a cluster like Cassandra or Scylla. The first one up, do a Nodetool status. It shows you what the whole status of the cluster is. Which nodes are up, which ones are not, what their current status is, how much space they're consuming. Another one that's very commonly used is TPstats. It stands for thread pool stats, and it tells you what kinds of things have been going on in that particular node and whether or not requests have been blocked, whether or not requests are pending. Several people have mentioned throughout the day, pending is not something you want to watch for. It's very true, you want to watch for it. So TPstats is one of the commands that'll help you to see what's pending. Table stats is sort of like MySQL's show table status. Very similar. Actually, it provides a bit more detail than show table status does. Show table status just gives you basic and background information about the table. Show table status will actually show how many reads and writes have been done against it and things like that. Table histograms is something that there is no corresponding equivalent. I shouldn't say that. if you use the sysschema and kind of play around, you can get the similar kind of histogram out of sysschema or from the performance schema. But you don't see it from any of the show commands in MySQL. Proxy histograms is a useful one as well. It tells you from the coordinator's point of view, how are things performing in this particular node. Again, remember, it's for that node. It's not going to tell you at the table level. It's going to tell you at the whole node level, requests that are coming in, requests that are going out, and how well they're being serviced. And there's lots of other commands as well. Nodetool command list is about 2 or 3 screens worth of data if we need to display a list of help. Here's an example of a Cassandra Describe. It's kind of small. For those of you near the back of the room, you probably can't see it too well. But realistically, you describe, here's one, describe modal 1. It shows the key space with regard to that particular key space, which is basically the equivalent of a create database. And then you see the create table looks very much like an ordinary table definition. And then you have also got information that's related to the clustering information. And then I've cut it out, but there's a whole bunch of other information down there that relates to compaction strategy and repair strategy, things like that. Nodetool Status. This is probably the most useful command. Pretty much everyone uses it on a pretty regular basis. And it basically shows you, I've got 2 data centers, which is 2 sort of subclusters. Of each of the 2 data centers, I've got 3 nodes. In this particular case, they're all running on my local host. They've got about 300 kbytes each. Because I use replication factor 3 in this configuration, they all own the data, so everybody owns everything. And the same is true in this one. UN stands for up normal. If it's down, that first letter will be a D, and there's a variety of other states that basically tell you whether or not a node is leaving the cluster. That'll be like with an L, or joining the cluster, things like that. Proxy histograms is the command that basically tells you information about, again, the whole node, not necessarily any individual table, what's happening across the whole node, how kind of response times I've got. So you can see here, the 50th percentile read latency is 454. Now you look at that and you say 454, that seems like a large number. Then you look at the fact that it says up above, micros. So that says the average read latency of this particular workload, which is just a Cassandra stress load, is 454 microseconds average. That's pretty fast. Worst case was basically 17 milliseconds. That's actually pretty humping. As people have mentioned before, the write latency is not necessarily quite as meaningful, and that really comes down to the fact that we're looking at what's happening on the local host, and it's really very limited. It's basically everything's being cached, so all you're doing is really operations in memory. So most of the time, that's going to be really small. Although it's interesting here, I got one that's 58 milliseconds. We've got range latency. That's basically when I do a query which is selecting a range of data from a particular partition. So these clearly take longer, which you'd expect because we're collecting more than one row. We have the rest of these, the operations were not being performed by this particular stress tool command. So they're 0. But this is at the proxy level. So this is showing requests that came in to a cluster coordinator on a particular node, and we're being sent to either local requests or remote. Nodetool Tablehistograms is the same sort of thing, only this time it's on that particular table. And here you see, and here's where you see the write latencies get really tiny. You see the number of SS tables. This is the actual number of SS table files. If you guys remember, there's some discussion about log structured merge trees and all that kind of good stuff and compaction. This is basically saying that in this particular environment, this particular table has 3 SS table files. And you can see here, again, my write latency is like 9.89 microseconds average. That's like tiny. The read latency is like 73. Now, this is on the local node. Now, if you have to remember that you have to go through the proxy, the coordinator, to get to this. So this is really kind of the bare minimum. It's kind of like what the node saw. Then that has to be sent back to the coordinator, and the coordinator sends it back to the client. So some of these numbers are going to look really small. Don't take them too seriously. Okay, TPstats, that's the one we were talking about earlier. With TPstats, you've got basically what we call pool names. These are thread pools. And here, and this is not uncommon, in a happy running system, I was actually running StressTool against this. And the StressTool was running, driving, I think it was writes at the time that I did this. It was driving writes is fairly hard. And as you can see, I have 0 active operations in any of the threads, and I have 0 pending. In real life, you usually see a few active and an occasional pending, and that's okay. But if you see consistent pendings, that's usually a bad sign. That's telling you that the cluster is getting constipated, or at least this node is, and you need to start looking at what's going on, what's causing it. In Cassandra, very often that's a garbage collection. Garbage collections are the bane of Cassandra. One of the things that I really like about Scylla is it doesn't have those. But you can see here, I was actually did a whole bunch of operations. My read stage, that's basically read requests. Compaction executioner is the compactions. So I actually compacted a fair amount during this test. Mutation stage, don't ask me why, but they don't call it writes, they don't call it updates, they call it mutations. So what you would think of as a write or an update in MySQL is a mutation. So that's basically the number of writes that were performed. Memtable reclaim memory, basically it's pulling memory back after it's written a memtable. Gossip stage, the nodes have to talk to each other all the time. So this is basically how many times this particular node has talked to other nodes. Request response stage, that's basically the coordinator. So how many requests came in as a coordinator function. Native transport requests, that's information that came in via the native transport, the binary connection. Migration stage, I got 0 here since I wasn't migrating any data. Memtable post flush, there should also be a flush in here. Oh, the flush writer added out down here. I got the flush writer that basically, this is how many times I flushed memtables. And these all match together because I post flushed it and did the per disk flush. What's important here is I didn't have any blocked operations. Blocked operations are bad. You see blocked operations, that means you got constipated, you basically stopped and failed to do a particular operation. It was dropped in the hole. And all-time blocked is the most that you ever blocked at any one time. Tablestats, that's the one where you basically do the same thing as a MySQL show table status. That's actually really useful information. You see here at the top, it's the read count. This is the total number of reads that were performed. Now this is not particularly useful because it's an average, but this tells you the read latency, and this is in milliseconds. This is the average read latency to this table. Again, it's the read latency at the node. It's not the read latency that the coordinator saw or that the application saw. It's the read latency that that node saw. You see the write count here and write latency. And as you can see, write latency is always much, much tinier than read latency. That's normal. Completely different from any other database you probably ever worked with. Most databases, write latency is always much bigger than read latency. Cassandra and Scylla are both optimized to do writes. So it's very, very, very streamlined. And again, as was pointed out earlier in some of the other presentations, it kind of really lies about what's really happening because it's only showing you a little bit about what's happening with the write. Because all that writing is buffered. Whoop. Let's see here. Pending flushes, 0. The table name, SS table count number, this is one has 5 now. Space used live, which is basically, in this particular case, they're the same. Space used by snapshots, I didn't do any snapshots. It's important to keep track of that. I've seen, I don't know how many customers I worked with, they do snapshots and they lose track of them, especially if they're using auto snapshot. They delete a table and recreate it, and they're like, why didn't my space go away? Why am I still consuming that space? Well, you had auto snapshot turned on. So you want to keep track of that. Off-heap memory, this is how much memory you're using that's not on the heap. SS table compression ratio, not so good here, but that we're using really tiny tables, really tiny rows, sorry. Number of keys, this is an estimate. And this is an estimate for the number of keys in this node. So there may be more keys. In this particular case, there won't be because I had replication factor 3, and I was using only 3 nodes, so it's all replicated. But in most use cases, this is going to be different on each node. Mem table cell count, that gives you an idea how many cells there are in the mem table itself, not in the whole thing. Mem table off heap memory used, 0 here, okay. Switch counts, 65, that's basically how many times it got dumped. Local read count, local read latency. Same thing for write latency. Bloom filter, false positives. Cassandra and Scylla have something called the Bloom filter. It's a mechanism for determining whether you want to even bother looking in this particular SS table file for your data. What it does is it takes the partition key and it takes the whole primary key really, and hashes it, and then folds the hash and stores that in a cell inside the Bloom filter. And the first thing it does when you try and read from a particular SS table file is it looks at that and says, hey, does that happen to match? You know, does that folded hash actually represent what I'm looking for? If it does, then I'll go look to see if it's in the table. If it doesn't, I don't need to ever look because I'm guaranteed it won't be there. Unfortunately, if you've got a lot of SS table files, or if you have a relatively large fold over so that you're only storing a few bits per key, there's a high probability of a false positive. False positive means you have to go look and find it's not there. You'll never get a false negative. You'll never get a situation where the data is there, but you can't find it. But you may get the situation the other way around. And here in this particular case, my false positives was 247. Given the circumstances, the false positive rate's like 0.0001. I'm not going to worry about it. The whole idea of the Bloom filter is just to save you some time. This is how much space the Bloom filters was occupying for this table. The index summary, this is how much space is being stored there. In one of the presentations this morning, they were showing the way the index and the way the Cassandra and Scylla index tables. And there's basically one thing called the index, and there's another thing called the summary. Summary is sort of like a second level index. And this is basically stuff that's stored in memory all the time. So you want to keep track of how much it's consuming, but it's something you just need to have there. You think of it as the root level index of your tables. Then you got some compaction information, average live cells per slice, average tombstones. There shouldn't be any tombstones in this particular case, but if you get lots of tombstones, that can impact your performance. There's a whole bunch of tuning parameters. There's not time for me to talk about it here. Next command we've got is Nodetool Describecluster, and I'm running out of time, so I need to hurry up this here. Describecluster basically just gives you an overview of the cluster, And this is something that you'll find is something you need to watch very closely. Because Cassandra and Scylla are both distributed clusters, when you issue a command to change your schema, it doesn't happen instantly. And as a result, there can sometimes be some really bizarre behavior. So one of the things you always want to do after you issue a DDL command is issue a describe cluster to find out that if all your cluster nodes have the same schema version. If they don't, you want to take remedial action. I've learned this the hard way many times in Cassandra. I've not had that experience yet with Scylla, but that I haven't done a lot with Scylla yet. Alternatives to the command line. Everybody likes command line. Well, no, actually a lot of people don't. There are alternatives to using the command line. I'm not going to talk about management, but I'm going to talk about metrics and graphs, pretty graphs and things. Why do we want to do this? Well, first of all, it's nice to be able to put it all in one place and see it visually, not have to sit there and look at a bunch of numbers and try and crunch them through. So you'd like to have history information. You'd like to be able to see it on the fly, a graph. You want to be able to generate alerts. You want to be able to say, hey, I don't want to have to go out and poll periodically to find out what's going on. I want it to tell me when something's wrong. You want aggregated data from all nodes at once. You want to be able to put them all in one place and see what's going on. And finally, you want to be able to do correlations between the various graphing entities. You want to be able to correlate pending data to response time, for example.